The topic of this video is graphing transformation techniques, vertical and horizontal reflections. Let's look at a problem. Graph the function f of x equals the cube root of negative x. Okay, so the first thing we want to do is to identify our parent function, our basic function, that has been transformed to create this. Hopefully it's obvious to you that that's the cube root function. We started with f of x equals the cube root of x, and then we transformed that into this function. So you should know all of the points from memory associated with the cube root of x, and they are -8, -1, 0, 1, 8 for the x's, -2, -1, 0, 1, 2 for the y's. And if we were to create a quick sketch of the cube root function, here's what it would look like. So now we have to figure out how are this and this different, because that will inform our decision making regarding how we should come up with the graph. Well, the only difference between this and this is that little minus. So we ask ourselves the very important question. First, how are they different and where? Well, we notice that there is a minus, and that minus is inside close to x. When the observed change is inside close to x, that is indicative of a horizontal transformation. Next question we should ask ourselves is, what changed? And that would be this minus. This minus is representing a multiplication by -1. And that is indicative of a reflection. Adding or subtracting is a shift. Multiplying by a positive number is a stretch or a shrink. Multiplying by -1 is a reflection. So in this particular problem, we are dealing with a horizontal reflection. Okay, great. So we know that for a horizontal reflection, we are spinning our graph around the y-axis, which means anything that used to be on the right is now on the left. Anything that used to be on the left is now on the right. And therefore, all of the x coordinates are going to change sign. The y coordinates do not change. Okay, so if the y's are not going to change, we can go ahead and write those values here. But the x's are all going to change sign. So instead of -8, we'll have +8. It's -1 becomes +1. 0 stays 0. 1 becomes -1. And 8 becomes -8. All right, now we're going to create the graph using the points that we have found. We know that we need to go all the way out to -8 and all the way out to 8 on the x-axis. So that means -4 would be here, 4 would be here, -2 would be here, 2 would be here, -1, 1. So that tells me where 1 is on the y-axis and where 2 is on the y-axis, and -2. Okay, so then we're going to plot our points. 8, -2, that would be over here. 1, -1 would be here. 0, 0, here. -1, 1, here. -8, 2, here. We connect our points together. And this is our final picture. This is the graph of f of x equals the cube root of -x. Now, I'd like to say this is the end. We're done. This that we've shown here in blue is our final answer. But sometimes students find it helpful to see the parent function and the transformed function on the same graph grid. So I'm going to plot these points over here on the same graph grid. So -8, -2, which is here. -1, 1, which is here. 0, 0, 1, 1, 8, 2. And when we connect those dots together, we get this picture. Now, if you think about it, if you take the black curve and you spin it around the y-axis, it's going to create the blue curve, and that is indicative of a horizontal reflection. My hand is moving horizontally. Okay, that's the end of this problem.